Good afternoon or good morning to everyone. So today, especially, we'll discuss about the transitive closure relation. So first of all, we discuss here transitive closure relation. Transitive closure relation. Closure relation. Just to remember what is transitive closure relation. What is the transitive closure relation? The transitive closure R plus. Just we can define R plus. The transitive closure relation R plus. Transitive closure relation. Right? The transitive closure relation R plus is the smallest transitive relation. Is the smallest transitive relation. Smallest transitive relation is the smallest transitive relation that contain R is a subset that contain R is a subset is a subset defined on A. Defined on A. And A contain M elements. A contain M elements. This set A contain M elements. So R plus can define here. R plus can be defined here. That is R union of R square, union of R cube, union of that up to continue number of elements contains in set A, that is union of R to the power M. So this is R plus, or this transitive closure relation. We can say that the transitive closure relation again we define here. It is the smallest relation contains R. R plus is the smallest relation contain R, is a subset defined on A. R is the smallest relation, right? Defined on set A. And set A which contains the element of A. Suppose R plus also define here R union, R square union, R cube union, R to the power M, this process. Just we are coming to some examples to discuss here. For the transitive closure relation, so let A one example. A set is given here. Set A is defined here 1, 2, 2, 3, 3, 1. That is relation, sorry, this is relation I defined here, relation R is defined here. So we can define a relation that is R. On given set A, how many elements are there? 1, 2, 3. These are the elements. Find the transitive closure. Find the transitive closure. Okay. So we need to just find out the transitive closure. What is the transitive closure? Here it is given one relation. Just mention here one relation is mentioned here. So here this relation is given us. Given R. And that relation is mentioned 1, 2, 2, 3, 3, 1. And A set also given us, that is 1, 2, 3. This is given to us. So when we convert into matrix and R square, we can define number of elements is this 3. So R plus is required here. Number of elements is 3. So R plus is required here. R union of R square union of R cube. This is the transitive closure property, whatever we have referred the R relation, R square relation, R plus relation. Those all the relation we combine here, and this is called the transitive closure property in general. So we define here why this is also used by the matrix method, or that is R into R, you can multiply the matrix multiplication process. So first of all, we define your matrix process. R is defined in the matrix form. That is how many means 1, 2, 3. That is one matrix is given here. 1, 2, 3. 1, 2, 3. And this is R is given. 1, 2. 1, 2 is first relation 1, 2. Step 1 and 2. This is 1 is naming here. 2, 3. 2 and 3. This is 1 is naming here. 3, 1. This is 1 is naming here. Other elements should be 0. This is 0. This is 0. And this is 0. 0. 0. 0. This is R we define in the form of matrix. Again, we have to recognize R square. That is a composite relation I just can produce. R square. We can composite relation, and that we define here R composite with R. That means just we can product of this matrix multiplication 0, 1, 0, 0, 0, 1, 1, 0, 0. Again, another R is multiplied here 0, 1, 0, 0, 0, 1, 1, 0, 0. That is a product of this. First, we can define the product of this matrix. What is its product? First row, first column. So 0 into 0, 0, 1 into 0, 0. So first elements 0 is given. Then second, first row is multiplied with first column. Then that is 0. First row multiply with second column. 0 into 1, 0, 1 into 0, 0, 0 into 0, that is also 0. First row multiply third column. 0 into 0, 1 into 1, 0, that is also 1. And second row multiply with first column. So this is the case of the first column, first row multiply first column, second column, and third column. Then we find this result. After that, we can use another term. Now we can multiply another terms. See, second row multiply with first column. 0 into 0, 0 into 0, 1 into 1, that is 1 we can say. 0 into 1, that is 0, 0 into 0, 0 into 0, that is also 0. And 0 into 0, 0 into 1, 1 into 0, that is also 0. So we complete, this is the third step, also we have to complete it, and second value we can evaluate here. Then last we also multiply here. Another value, just see what is the next value. We can use this value, second row is finished, right? So 0 last row in first column, that is 0. Last row is second column, that is 1. 0, 1. Last row is third column, that is 0. So just we evaluated here R square. But our objective, what happens for transitive closure? ट्रांजिटिव क्लोजर के लिए मुझे ये चाहिए कि R plus, that is defined here, R we already found, R square you evaluated. Again we need to evaluate the R cube. After that they combine together to produce the R plus. So just we evaluate R cube. And R cube, how to evaluate? R cube we can evaluate it now. R square relation also we can produce here. So R cube can be evaluated here, that is R square into R. Just remember R square composition with R. So R square is already evaluated 0, 0, 1, 1, 0, 0, 0, 1, 0. This is R square and multiply with of R. What is the R? 0, 1, 0. 0, 1, 0. 0, 0, 1. 0, 0, 1. 1, 0, 0. 1, 0, 0. So this is the relation of the R cube. And just we need to evaluate this value, the product of this value. First row, first column, that is 1 we produced. And first row with first column 1, first row with second column 0. First row with the third column, that is also 0. First row, second row, first column, that is 0. First row, second row, second column, that is 1. Second row, third column, that is also 0. And last row, first column, 1. First value is 1. Then last row, second column, 0, 1. That is 0, 1. You produce, that is R cube. And just to remember, R cube, what is the relation? 1, 1, 1, 2, 1, 1, 1 relation, 2, 2 relation, 3, 3 relation is there. Again, you can see what is the product of the R square. First row, 1, 0, 0, 0. Last row, this row multiply this column, and that is produce the 0. In this row produce this column, that is produced 1. and this row produces this value, that is relation 0. 0, 1, 0. So actually I mistakenly written that is actually 0, this value is the 0. Okay. So last product is 0, 0, 1, 1. This is last and this is 1, 0. In the middle part value, that is 1. 0, 1, 0. 0, 1, 0. This value is 0 and this value is 1. This is 1. 1 and 0. So RQ relation, just you can check what is the result actually. R square 1 first 0, 1 second 0 third 0 second 0 first 0 first 1 then 0 first 0 second 0 third 1, right? This is third one, right? This is the value actually I've written. This is 0, 0, 1. Just you can see this is 0, 0 and 1. So RQ relation is found here. So just remember what is the relation of RQ. Now RQ can define this relation I've written here. 1, 1 relation, that is 2, 2 relation, and that is 3, 3 relation. That is our relation is produced. 1, 1, 2, 2, 3, 3 relation is there. And R square also relation. R square relation is defined here. What is the 1, 3 relation is there. 1, 3, 2, 1 relation is there. इसके प्लस 1 है तो ये जो वैल्यू है that is 1 and 3 के बीच में है. First row, third column, that's why we can return this value. Second row, first column 2, 1 and this is 2, 2. That is relation 2, 1, 2, 2 relation is there. Right? 2, 1 and 2, 2 relation is there. 1, 3, 2, 1 and 3, 2 relation is there. This is 3, 2 relation. Just remember, this is 3, 2 relation. So R relation is we already defined here. R square also you evaluated that. RQ also evaluated value. Then what is the relation transitive closure value? So we can just transitive closure you can define here. R plus. So transitive closure. Transitive closure relation. Define R is defined, right? That is R plus define R union of R square union of RQ. So we can just combine first relation 1, 3, 2, 1, 1, 3, 2, 1, 3, 2. That is first relation. We combine this result R square. What is R square? 1, 1, 2, 2, 3, 3. That is R square relation. Union of RQ relation. That is what is the RQ relation? Already given here RQ also we find here RQ relation 1, 2, 2, 3, 3, 1. 1, 2, 2, 3, sorry, 1, 1 relation. Sorry, 1 minute, just I have written wrong. 1, 1 relation is found here. 1, 1 relation, 2, 2 relation, and 3-1 relation, 3-3 relation. This is, we need to combine it actually. So whenever it is repeated, 1-1-3, 1-1 relation first is given, so we can retain here that is 1-1 relation. When it combined to produce some relations, so just to define here, 1-1 relation we can define. 1-2 relation is present here? No, 1-2 relation is not there. 1-3 relation is there. So we also write 1-3 is the relation. First of all, we define here 1-1 relation. Then 1-3 relation are written here. Then 2-1 relation is there. So we can define also 2-1 relation. Then 2-2 relation. 2-1 relation we can define here. This is 2-1 relation. This is 2-2 relation. So we can define the 2-1 relation, then 2-2 relation. 2-3 relation. 2-2 relation is double, so we can retain in a single time. 2-2 relation and 3-1 relation. 3-1 relation is not there, so we can write the 3-1 relation. And 3-2 relation is there, so we can write the here 3-2 relation. 3-2 relation. 3-3 relation. 3-2 relation already defined here. So 3-2 relation and 3-3 relation. That is repeated a 3-3 relation, so we can write the single ones. So 3-3 relation is also written. This is 3-3 relation, right? So this is the transitive closure, okay? So we can say that this above equation is called as the transitive equation or transitive relations. Okay, thank you. Right, understood? Then this is better for you. So we evaluated this transitive relation. Okay.